How did your interest in the field of immunology arise?
So I did my undergraduate studies in Australia, in Melbourne. I didn't want to be an immunologist. Actually, I went to university to become a meteorologist, so to figure out the weather. And then, I gradually needed to find a job at work, and I got a job in a lab that was working on a plant biology. So then I started to take genetics courses, and that bled into immunology. And I grew to really love immunology. There were two professors. One's name's Francis Carbone. The other was Stephen Turner. And they're the ones that got me into it. And it just kept snowballing into, how do B cells develop. And I got a job at a place called WEHI in Melbourne, which is an immunology institute, and started to work on this disease called acute lymphoblastic leukemia that I didn't know anything about going into that. But it turned out it was a really great system to learn about immunology. So that's how it was very chance-driven.
Can you tell us about your current research project?
I'm leading a lab at the University of Colorado, Anschutz medical campus in the United States. So our current research focus is on patients that basically fail chemotherapy with acute lymphoblastic leukemia. So trying to figure out ways that we can actually target those cells that have failed all these different types of toxic agents. And one way to do that is to use a patient's own immune system to combat the leukemia. So we're pretty much working now on a tool called chimeric antigen receptor T cells, where you train a patient's own T cells to combat their cancer. So that's one of the major projects. The other one is just simply to understand how the microenvironment that the leukemia survives in actually informs how it responds to therapy. So there's a few projects ongoing, but it's really about trying to fix those really bad cases of ALL who failed therapy.
What is the relevance of studying the tumor microenvironment?
I think tumor microenvironment in leukemias is somewhat of a new field, I would say. Really, most of the research so far over the past few decades in at least acute lymphoblastic leukemia are trying to understand the genetic events that cause a normal immune cell to transform into this devastating cancer. The microenvironment now has become really well appreciated to actually support the growth of the cancer cell. For example, in leukemia, work from the United Kingdom and the United States through the Ikaros lab, the Bonnet lab, and Aifantis lab were able to show that in the bone marrow, leukemia cells can actually home to blood vessels in the marrow to keep them alive. And if you target this interaction, the leukemia cells are now very vulnerable to cell death. So that tells you that they're talking to their environment to survive. We performed some work, and there's been many other groups that have done a really great job understanding how the immune system starts to see tumor cells in leukemia and try to combat those cells. But it's still in its infancy, and I think many groups around the US and the world are starting to appreciate that the immune system's sometimes trying to attack the leukemia, sometimes it's not. There's other cells around that are trying to keep the leukemia alive. So can we intervene with these interactions and improve how a patient would respond to therapy?
As a young scientist, what have been the major challenges you have faced?
For me, I think the biggest challenge personally that I had as a child, I think was that I tried to compare myself to everyone all the time. When I was doing my PhD, when I was studying my postdoc. And that became a real problem because you start to doubt yourself a lot. And also, there's no real reason to compare yourself to other people's success. It's all about how you're growing as an individual and how you're figuring out how to do this job yourself. And you should actually celebrate the other people being successful because it helps everyone. I mean, you know more about the field and succeeding, which is just great. I mean, it's easy to say this. Obviously, we're in a field where there's grant money that makes things competitive. It's hard to publish papers. But I always try to go back to thinking, well, 5 years ago, I was nowhere near this point in my career, so I've come a long way. I still have a long way to go, but I should only measure myself against myself, because I keep finding other things to measure myself to. There's always going to be someone significantly better than I in my mind. So I don't just see how I can developing as a person. That's been the biggest challenge for me, maturing as a young scientist does.
What would you like to say to the next generations of aspiring immunologists?
I think in the end, the job, you want to enjoy what you're doing as best you can. So go to an environment where people want you to grow, want you to learn. That's really important. This job can be really hard. There's no doubt. Sometimes you'll get results that don't make sense. Sometimes you'll get no results. Other times you'll really be thriving. But if you're in an environment that cares for your future, cares for you as an individual, it'll just make for a far better experience as an immunologist and a scientist in general. So I would say focus on what makes you happy in the field, find an environment that promotes that happiness, and everything else is a bonus after that. So yeah, that's what I would say.